Hello, I'm Marco Gandolfi speaking. I'm the host for the talks we will have this morning. Um, I will introduce some of the speakers, have some chat of them, introduce their talk, and so on. Let's start with the first speaker that has been submitted for call for paper. She's Axelle Apvrille. She's a principal security researcher at Fortinet, and she's she is specialized on malware for smart devices, um, whether they can be smartphone or other connected devices, IoT, and so on. So she typically goes under the handle Cryptex, CryptoGo, etc. As in earlier life, she implemented some crypto algorithms. She has been also the head of the international crypto group in his previous life. This means so she was animating an internal group of crypto experts, writing crypto algorithm, providing some advices on cryptographic algorithms, and doing some studies. She's also the lead organizer of PHO, so an annual Capture the Flag dedicated to smart devices. And so as you will see, she likes to hack, to create, and learn. So this talk she's going to present focuses on malicious Android apps which fake or abuse medical situations. So we'll follow some reverse engineering live of a COVID-19 malicious app and the demo of a useful tool she developed for first static analysis, let's say reverse engineering. So this can be something really interesting, in my opinion, for larger scale analysis of APKs and so on. We will also discuss about other medical malwares on Android and some, and she will also provide some advice as other cyber hygiene while using your Android smartphone. Okay, so I have to. So let's start with a video, with a talk, and we will meet Axelle right after the talk for a quick question and answer. So let's make sure that you will post your answers during the talk live using nohat.it/live. There is a Slido iframe where you can choose the access room and put your questions there. Don't be afraid to put questions. You can also write in Italian. We can translate them later. Okay. Bye.
Good morning, and thank you for joining this session. After, well, an entertaining keynote on humans in cyberspace, we are going to discuss now malware in cyberspace. More precisely, it is going to be malware affecting medical applications. So let me go to my next slide. There we go. What you're going to notice in this presentation is that, well, there are only 10 slides, which is pretty short, right? This is because most of this talk is going to be about the live reverse of an interesting malware on this topic. However, to be honest, 30 minutes is most of the time not sufficient to go in depth in the reverse engineering of a malware. So if you are interested really into digging into this malware, well, you can have a look at some 2 articles I wrote on Medium. This one is part 2 and part 1 is just below. So you go to cryptex.medium.com and you will locate the articles without any issue there. So it will help you, just go further and finish the reverse engineering of the malware. So who am I? Well, I'm a malware researcher at Fortinet, and I specialize in the reverse engineering of mobile malware, mostly Android, and also lots of malware on IoT. Okay, so any kind of strange malware usually ends up for me to look into more precisely. I'm also the lead organizer of Phone CTF, which is CTF, which is dedicated to challenges on smart devices. It's a local CTF, but it's not very far from Italy, so it is close to Nice in Sofia Antipolis. If you happen to be there or want to and are able to travel to France at that time, we'll be glad, of course, to see you. So, it's not obvious for everybody that there are actually lots of medical applications on smartphones, okay? For people who need it, of course. But there are really lots. For example, those two are for people with diabetes. It's quite typical that medical conditions which are chronic, well, people tend to develop applications to help people cope with those, and this is usually quite usual on an Android smartphone. For instance, to know how much you have eaten or what was your latest glucose level, things like that. Some other apps are connected to smart devices, and this is the case of those two, where it's connected hearing aids, and they are connected to your smartphone, okay, and you can just adjust the settings of your hearing aid so that it's okay and it works the best way for you, okay. What do we have else? Also, we have those three, which are if you want to see a medical doctor, okay, you get a video with a doctor and discuss this or that problem. This is for menstruation for women. Of course, you've got lots of applications for that as well. You've got applications for cardiac issues or cardiac care. So this one is for My Care Link, and it helps, well, you can read information from your pacemaker or your defibrillator and send it afterwards to the medical servers or to a doctor, and this is the app that helps for that. This one, I think it is connected to a smartwatch and warns you when you are close to having a seizure. You've got those three are COVID related, okay? This one you might know, we will discuss it quite a while afterwards. It was developed in Italy. The other two are French applications. This one is an application if you are traveling to Sicily. And yeah, okay, I think I've basically covered all, but you will find them. If not, you do check on Google Play and you will see what they are for. And there are lots more, of course, which are used for real medical issues, okay? Now, the issue, and we are going to discuss in this talk, of course, is that all those apps, well, there are also malicious apps. Well, sorry, I've got to make this clear. Those are genuine applications, okay, they are fine, okay, but some other times they get infected, compromised by a malware author who injects a malware in the application. That's one possibility. Or malware author creates a totally fake application, and that's how we have what I call medical malware. Okay, so those are just a list, and I've cut it, okay, about malware for diabetes, or which are affecting applications that are meant to cope one way or another with diabetes. Those are for psychiatry. Those are, for instance, for chronic diseases, chronic bronchitis. those are for leukemia. I can't really understand, yeah, how somebody would intentionally infect such an application, but um, of course you are probably aware that most of the time this is totally automated. Okay, cardiac issues, cardiac arrest, cardiac nursing care plans, cardiac cane. I mean, there's lots of things, and of course COVID-19. Nowadays, with many apps, and also many fake apps, and also many infected apps. Okay, so this is precisely the topic of this talk. So, what do you have in those malware? Well, pretty much what you find in any other malware. You've got lots of adware, spyware, scams, lots of those. But you also have the typical malware like ransomware, screen lockers, crypto lockers, which are encrypting your files, screen captures, recording audio, keyloggers, I don't know, whatever. Everything that you actually find usually in other malware. So that's the bad news. The good news, however, is that so far we haven't ever located any malware that is really manipulating medical values, like a malware that would connect to your pacemaker and have it stop or have it work in a normal way. Okay, this does not exist. It exists in fiction, and it has been very much discussed because it is a kind of a typical scenario, but it does not, fortunately, exist for real. It could, however, exist. It's not technically impossible, and especially for very important people, there is a risk and something perhaps to look into. If you're not a VIP, like I am not a VIP, your main concern will be with lots of the other possibilities for malware that you can have. Typically, a ransomware. If you have medical malware, which is a ransomware and which prevents you from using this or that medical device, or just making your smartphone unavailable and you can't communicate any longer with this or that medical device, this is going to be a real issue, okay, for you. So that's what it is. That's the kind of the status. The one now we are going to reverse live is this one. It is a COVID-19 contact tracing application, and as NoHat was meant to be hosted in Italy, I thought it would be interesting for everybody to target more specifically an application which was developed in Italy. So it was developed around March 2020, perhaps a few months, a few weeks before, and of course the application which was developed was totally genuine. I mean, it's not a malware, okay, but it got targeted by malware authors, and malware authors decided to repackage it and insert some malicious payload in the malware. If you want to find exactly the sample I am going to look into, it is there, and those are the two reference articles where you can find the remaining of the study if you wish to. So I want to show something more. So yeah, this is a very interesting report there, CTI investigation into COVID-19 contact tracing apps. It was in July 30th, and that's where actually I saw the mention to this application. And you go down there to all the list of COVID-19 malicious applications, and for Italy you find this one, SM_COVID-19, and that's where it says, okay, I hope it's readable for you. It says repackaged application injected with Metasploit, which is a bit strange the way it is formulated, because Metasploit is not a malware, it's just an infrastructure to test various exploits or to develop exploits, right? So I thought, what exactly do they mean and what does this look like? Okay, so I grabbed one of the samples, and that's what we are going to reverse now. So the first thing I am going to show is actually a video of the malware in action. So no, I am shifting to the right place. It is over there. No hat, videos, and there we go. So there, I'm getting the sample. That's the sum of the sample I mentioned in the slides before, and I'm installing it on an emulator. Okay, we're working on an emulator. It's always safer. So then, well, it installed, as you can see. Now what we are going to do is that we are going to get into the hands of an attacker and see what's from the attacker's side, what is going to happen. But first of all, we need to know what is the IP address of the attacker, and this IP address is mentioned in the sample. It is hard-coded in the sample, so we need to find it in the sample. So I unzip the sample, as you can see, and then in the Dalvik executable, I am going to look for the IP address. There it is, that's the IP address, and with the specific port. Let me jump a little bit. So now we're going to redirect this IP address to my own laptop. Okay, so that everything that was meant to go to the attacker will actually go onto my laptop where I'm going to run Metasploit. So I had done the redirection previously. I'm jumping a little bit forward. We are going to start Metasploit. Well, that is Metasploit's console. So this is from the attacker's perspective again, okay? And we are going to use a specific exploit, which is a reverse shell meter preacher, okay? So we get it from the Android directory, reverse shell, reverse TCP. And then we've got to specify, well, the IP address of our host. My host there is locally on 192.168.0.42, and then we need the port 24079, and we launch it. It is a reverse shell, so it is going to wait for an active connection to come from the victim. So the victim on the emulator clicks on the application, which looks perfectly real, as you can see. And on the other side, the attacker immediately gets a shell where, with plenty of commands, he or she can issue. So like listing all apps on the phone, checking if the device is rooted. Well, it's an emulator, so it's rooted. In that case, we can dump SMS, and we can read the SMS which were on the emulator. So there, okay, I love messages about chocolate, so don't forget to buy chocolate. If you go actually on the smartphone, you can check that those are really the two messages which are on the smartphone. Even better, you can also dump the contacts. Again, it's an emulator, it's done just for tests, so what you get as contacts, as you can see, it's John Doe. Not really interesting, but we can check that indeed we have John Doe listed as a contact, and that his phone number is the correct one. So no, I don't need that. And sign deny access there, John Doe, and the phone number is correct. What else can we do? Well, we can try actually, if you want, you can set that up and try it at home or at work. There are plenty of other commands. You can list webcams. So you've got a front one and a back one. And you can try and get a snapshot. So here I'm getting a snapshot of the back one. This is the emulator. Okay, so it's normal that you get this specific picture. It's a hard-coded picture. Yeah, that's not extremely interesting. And we can get also a screenshot. So yeah, you can't get a screenshot if unless you are in the application, which is compromised. So I'm gonna launch the COVID-19 application, and there start again and try and do the screenshot, and you will see that it works really well, honestly. All of this, all the commands, I was surprised most of the time when you try something, it doesn't work immediately. Here I get everything. Yeah, it's exactly the same screen, okay, that we get. Okay, so this is really just to show you how the malware is supposed to work. Now we are going to reverse that. So I'm going to open the sample in Jeb. Jeb is a disassembler. It's a really good disassembler. The only issue with it, I guess, is that you have to pay for it. But if you want to, you can stick to open source and free software to do nearly the same tasks. The decompilers aren't always as good. It depends, but I like this tool myself. Anyway, we're going to have a look at the manifests. You can see that there's lots of permissions, but it's not obvious initially, okay, if those are applications needed really by the real application, or if those have been added by the malicious payload which is inserted. We locate over here the main. So the main is going to be called IT Soft Mining Project COVID-19 Safe Lifestyle main activity. Okay, and then there's something interesting. So this IT software mining project namespace is the real namespace of the real application, the genuine application. But what is strange is just afterwards, as a service, we can see this obfuscated name, XMEVV, and this is a little bit strange. Okay, so we can go and have a look, and we're going to go in there, and all those are the files of the real application. And then there's one directory which is obfuscated and with several other classes which are obfuscated as well. So we go in there and we see this is a service. It is calling another one which is obfuscating and starting, calling the start method. Here we see it does some reflection calls, okay, calling current application. This is not extremely, you wouldn't see that really in a normal application most of the time. It's kind of a little bit suspicious. It can be for real, but it's slightly suspicious already there. So we're going to have a look at this one, which is mentioned there. So this one is a little bit bigger, so it takes a little bit of time to decompile, but the soft is pretty big, pretty good. Come on. There we go. And there it decomposes, and you see there's very large byte array. Okay, so pretty strange. Again, doing something about get packet manager. This, if you are used into seeing something like that in malware, this is something that hides the application icon. So, you know, this is really looking strange. Then a little bit later on, you see that, well, you know, we are obviously loading a DEX there, and then calling a method called start in that DEX. Again, this happened in some aggressive adware, but really smells bad. Okay, and then we go a little bit down there. We see that it's using a socket. Interesting, somewhere. This is about typically seeing if their smartphone is sleeping or not. So this is typical power management. And then, server socket or socket over there. And there's a connection, URL connection. Woohoo, this is really suspicious, damn suspicious. So there are actually several ways to know what is suspicious. We know that it was in, that something about meter-preter reverse shell was injected in the application. So we can go and have a look at the sources of that, because the sources of this part of our open source, and you can have a look at it. The most difficult part is actually to find the URL where to find this the source. And here we see this one, payload.java, and it really looks like the same. Okay, we see there's an array of configuration bytes, so it seems. Then again, we get that method call to the current application. We had seen that one. Again, power management requiring that, hiding the application icon. And a little bit down there, connecting to a given URL. Then even more, we have those things about using a server socket or a socket depending on if the host is provided or not. Loading bytes. And here, here we have loading a DEX and calling method start. So there it is. Okay, we have located our meter-preter in here, and this is how it works. So we can have a look at that. Okay. So the other way, because it's not always that obvious at first that this is the malicious class. The other way, if you want to pinpoint it, that it is located, it is located, I'm gonna get it, it's this one, that it is located in this namespace APZCP from IT, soft mining projects in there. The way to do that is to use droidlysys. So droidlysys is a tool of mine. Okay, so this is shameless advertisements. No, I'm joking. It's open source, so okay. You can use it or not, like it or not, improve it. You're just welcome to do that all the time. It's I find it personally pretty useful at first when I'm beginning a reverse engineering, because it explains. Well, it shows what calls, API calls are being done on your sample. And then from there, you have kind of entries of which are maybe a little bit suspicious, and you can start and do your reverse engineering in those areas and think, oh, I found that a little bit suspicious, so I am going to have a look more precisely at that. Okay, so as you can see, takes a few seconds to process. Always too long when you're doing a demonstration. Hopefully it will end soon. It's usually just a few seconds, okay, to get the things processing and have it work. There we go, it's gonna show everything soon. Come on. Yeah. There we go. Okay, so you get everything about, well, the application, the activities, main activity, permissions, and things like that. But the thing which is the most interesting, in my humble opinion, is that the following parts there, which tell you that, okay, the application, well, the sample is using Dex class loader, for instance. Okay, so this is already kind of suspicious because it shouldn't really be used. It's using encryption, it's digging information from your package, retrieving the host IP address, okay, might happen, posting information via HTTP requests, using reflection, sockets also, and things like that. Okay, so at least in there, which when I see this, I would think, okay, this is unusual that an application is using sockets and using Dex class loader. I'm gonna have a look where exactly it is using that. So there you go in the directory. This was created by Drolizis. And in auto analysis, we are going to look for Dex class loader. There it is. And we see that all mentions to the class loader are from this ufweb class. There it is, ufweb. And then socket, same thing, ufweb. And socket here, ufweb again. So it already, it kind of gives you, okay, I've got to go and see in this directory. That's the way you can really understand where you have to go for your reverse engineering. Now, time is flying by, so I've got to wrap this session quite quickly. The last thing I wanted to show you there is how does this service get called. Okay, it is here, but how does this get started? So how it gets started is pretty interesting because actually, where is that? It's a little bit below, I think. Yeah, the application line here, you've got to read it through with details, and you see over here that it is, that it is a multi-dex application. Most of the time, small applications, you only have one Dalvik executable. But with time, this was insufficient, and Android introduced the possibility to have several Dalvik executables. And this sample, is using several Dex executables. And when you have that, well, you've got to tell Android that you're using that. And if we go, so in Android X multi-dex application, this is where everything is going to start for the application. And just see it there. This is where our service gets started. And this is really an interesting way of doing things, because the start of this malicious service is done from a class which is located in Android X multi-dex package, which is something which is from Google, and that most of the time you won't go and look into those that namespace, because it will be just the standard Android stuff. Okay, so you might miss that one, and this, I think, is an intelligent way of starting and stealing and remaining under the radar, kind of. So yeah, unfortunately I'm already slightly over time, so I'm going to wrap it up really very quickly. If you want to have more information, go and see my articles on Cryptax Medium, and you'll have even really more details on this particular sample. You've got also lots of other documentation which are already related to medical apps over there. And thank you very much for your attention. I will be available, of course, for question and answers, and also on Twitter, or you can send me an email. I'm always happy and glad to answer any of your questions. Thank you very much.
Hello
Hello.
again. Hello, Axelle. How are you?
Good. Thank you very much, Gandalf, and you.
So very good. So thank you very much for your talk. It has been very so interesting and practical. So I wanted to present you some of the questions from our audience. So they posted some question on the Slido chat in the dedicated room. The first question is related to the initial analysis you did. So related to these malicious apps. So were the malicious apps you listed published to the official Play Store, any other unofficial store, or only downloadable as an APK?
Okay. For the application we've been reversing live, I do not think that it was on the Play Store. It's difficult to know at this time because what happens is that I reversed this application around September, but it was out in March. Okay, so a long time ago. In terms of applications life, that's like, lives ago, just a few months. It appears that most people got this malware from phishing links. Okay, so it wasn't directly on the Play Store for that one. But there were other COVID-19 malicious apps which were found on the Play Store, and reminds me of it was India's Arogya Setu contact application. One of those was so compromised and found on the Play Store for a couple of hours or days. I can't exactly know. So,
okay.
Short no for this one, but yes for others.
Good. So, so this is my question. So, do you think an approach like the one you presented, so quite automated for the initial analysis of, at least for an initial reversing, could be applied or is applied by Google when vetting the applications that are played on that are published on their store?
I think that the way I do it and do the reversing is it's maybe not that easy to automate it. It's easy when you have when you're a human being behind it, because you kind of intuitively know where to go or what is a bit strange, but it's not always that easy. In that particular case, I reversed 3 different applications of that Italian contact tracing application. Three different malware, and one was extremely easy to reverse because they had done absolutely no obfuscation at all, and it was just direct. We could see where the malicious part was. This one was well, the first one wasn't even working. This one is working, and it's like average work to reverse it. And the third one was really difficult, and unfortunately, it's the first one I started with. So I reversed the application, and at first, to be honest, I didn't know where I was going to find that Metasploit part in it. So it took me kind of a little time to locate it in the code, because you've got plenty of classes in there which are perfectly normal, perfectly genuine, and you've got to spot the right one. And of course, when the names are changed, it's not always that easy. So automating it, I'm sure that Google anyway has lots of tools to pre-screen the apps. But well, it's never going to match a reverse engineer doing the work for specific cases, at least.
Okay, so you partly also answered to the other two questions, probably. So the second question was, how many apps did you analyze in such campaigns? And the third question was if any other advanced techniques apart from repacking backdoors or abusing the intents have been used, and if you found any usage of native code, for example, and if yes, in which percentage?
Okay, so lots of questions actually. So if I identified other, how many I identified in those campaigns, I wouldn't be able to give a number, well, an exact number, because my focus there was really to understand how this application was working rather than identify all the copycats for that one. But there are at least more than 10, more than something like 50, and perhaps far more. I don't exactly know, but it's not just one isolated case, that's for sure. As for, well, advanced techniques, well, I'd say that already this one, which is injecting Metasploit, is not something usual in what we see in malware. Okay, malware which are live and that we see in the wild tend to be extremely simple in the way they are coded, and they go direct to the point. There's no use in using anything which is advanced when something which is extremely simple works as well. Okay. So this is already not common in there. We do not find very much people really repacking backdoors using native code. Yes, it does happen, but not very often. I did have some percentage, but it's like it's an old percentage from 2014, so it probably wouldn't apply exactly the same now. In 2014, I think it was less than 5% of malware which are using native code. In 2020, it can be pretty different. So I'm not sure this is really relevant to the question, unfortunately.
I think so, yeah. Okay.
And yeah, so yeah, just to answer again that question, when we are doing research and we are researchers and speaking to security researchers, they tend indeed to ask, do you have anything more advanced? If you go in the wild, it doesn't work that way. You don't have advanced things, but you've got loads of things to work on. Okay, just reminding that we have more than 25,000 new samples, new malicious samples for Android per day. Okay, so we've got to deal with that.
That's quite a significant amount.
Yeah.
So let me check if there is any other question on the
Sure.
on the Q&A. No, no other question for the moment. So I encourage the audience to continue to post questions on the Slido. Oh yeah, there is a question incoming. Let me check. Yeah. Axelle, Flutter framework is making reversing up much harder. What do you think? I don't know what Flutter framework is, but
okay, I'm checking because Flutter framework is making reversing apps much harder. Okay, well, unfortunately, I'm going to have a very silly answer. I don't know Flutter framework at all. Okay, so I'll check it out. And does that person mean maybe they can answer in the chat? Are they talking about the advertisement SDK for that? If that is the case, yeah, I've dealt with some of those, and any third-party SDK is always complicates the reversing. That's obvious all the time. I'm not sure we're talking about the same though.
For the moment, it didn't answer, but for sure it will. It will
Yeah,
use in the chat.
yeah. I see on the web. Flutter
Okay.
uses for native apps and record time. Okay, it's not the same thing.
Okay,
So,
if anyone wants to interact on these topics, feel free to continue using the Slido chat. We have in noahead.it/live, and using specifically on this topic the Axelle's room. It's Apvrille. Okay. Axelle,
okay, thank
I
you very
don't know
much.
if you want to add anything else. So thank you very
No,
much for your support, for your enthusiasm, and really for being part of a community, and as you demonstrated.
no, thank you very much. I hope I'll be at NoHat live next year, perhaps, and I'll hang out on in the room for a couple of minutes if there are any other questions. Thank you very much for you and for your patience and organization, and good luck.
Thank you very much. Bye, Axelle.